This is physics course 9702, past paper question from Unit 2, Kinematics. This past paper question is taken from physics course 9702, November 2024, paper 2-3, question number 1. And the question is beginning from the definition of acceleration. Very simple and straightforward question of 1 mark, in which it is being asked that student needs to define. The command word used here is define. Define acceleration. In reply, we can say, or we need to answer, that the change of velocity per unit time is called acceleration. As we all know, velocity is an already defined quantity before the arrival of definition of acceleration. So, a little bit condition is being imposed on the definition of velocity, and by using this definition of velocity, by using this name of the quantity velocity, we have defined another quantity of the syllabus called acceleration. What is this? This condition is the condition of 1 second. That whatever is the change in velocity of the moving vehicle in 1 second will be regarded as the acceleration of the moving vehicle. So change of velocity per unit time, which is also being translated into mathematical language by the people of physics as small a equals to small v minus small u divided by t. Small a is a symbol of acceleration. Small v is a symbol of final velocity or final speed. Small u is a symbol of initial velocity or initial speed divided by time. So when v minus u is divided by time, then it means we are writing in English language, or we can translate it in English language as the rate of change of velocity. Means the change in velocity in 1 second of the moving vehicle, the change in velocity per unit time, and mostly the unit time is 1 second, is regarded as the acceleration of the moving body. Then there is part B of this question, in which your examiner is asking for a small aircraft is flying horizontally at a speed of 42 meters per second at a height of 63 meters above horizontal ground, as shown in the figure 1.1. It is clearly can be seen from this diagram that the horizontal speed of 42 meters per second is being given. The vertical distance of the small aircraft as a 63 meter is also being given from the ground. The aircraft drops a small parcel. The parcel is released from the aircraft at the instant shown in figure 1.1. Air resistance is negligible. On figure 1.1, draw a line to show the path of the parcel as it falls from the aircraft to the ground. Look at that, beta. Look at this situation, my students. The situation is when the parcel is released from the aircraft, parcel already has the horizontal component of speed of 42 meter per second present into it. So obviously, it starts traveling in the horizontal direction. At the same time, the force of gravity of the ground starts pulling it vertically downwards. So the vertical speed, the vertical portion of the speed also starts to be building up which was initially zero at the moment when the parcel is being dropped from the small flying aircraft. So it means that there must be the two displacements present in the parcel, the horizontal displacement, because it does have the horizontal speed of 42 meter per second, and there must be the vertical displacement towards the ground. And the resultant of the two displacements will actually be the path of the parcel when it is released from the flying aircraft and when it goes towards the ground. As you can see here, I have tried to show the horizontal displacement by the help of a green color and the vertical displacement by the help of a blue color. And the resultant of both is being shown as a yellow color, and yellow color line is also representing a tangent line at a point of the path. The black line is actually showing us the path or the expected path when the parcel is released from the aircraft and then it is going towards the ground. So it will be a kind of such kind of curve in which you people can clearly see that from the point of release, the particle has covered. This is the point of release. This particular line is the reference to the point of release. And you people can see from this diagram, from this trace of the path, from this trajectory of the path, that the parcel has covered some horizontal ground or some horizontal displacement. Also, it has taken some vertical displacement. So that's why I'm saying that the final path, which is being shown by the help of a black color, is actually the resultant displacement, which is being adopted by the parcel, which is being covered by the parcel, because the parcel is actually covering both the horizontal displacement and the vertical displacement. You can see initially in the starting moment when the parcel is released from the flying small aircraft, the green color line or the green displacement, you can take it as a displacement, you can take as this vector quantity, which is representing speed or velocity. So this is larger, this is much larger in the beginning because initially the parcel has a horizontal component of velocity or the magnitude of velocity, which is equals to 42 meter per second, while vertically it was almost negligible. So initially the blue color is very small and the green color is representing that most of the resultant, which is in yellow color, most of the displacement which is being shown, resultant displacement which is being shown in yellow color, is in the horizontal direction and a little bit in a vertical direction. The process goes on, and as you can see from top, from where the parcel is being released from the flying aircraft to the bottom, where it hits the ground, the blue color is growing larger and larger. Blue color is becoming larger because vertically we can see that there is a rise in velocity. Vertically, there is a resultant force present. That's why, because of the presence of this resultant force in the vertical direction, the magnitude of velocity is growing in the vertical direction, which is actually the speed. But as far as the horizontal direction is concerned, you people can clearly see there is no horizontal force. There is no horizontal force present in the horizontal direction. So from start to the end, the green color line, I have tried to show the same size of the green color line because as far as the horizontal component of speed or the horizontal component of magnitude of velocity remained same, which remained equals to 42 meter per second, which remained constant. So there is no change of speed happens as far as the horizontal direction of the displacement of parcel is concerned. But as far as the vertical direction is concerned, the change will definitely happen. As you know, when object falls in the downward direction, the value of small g equals to 9.81, which is also called acceleration due to gravity. The acceleration due to the force of gravity is acted on the body. In every second, it is going to increase the value of velocity, the value of the magnitude of velocity equal to 9.81 meter per second per second. In every second, it is going to increase the value of velocity equal to 9.8 meter per second. That's why it is called 9.81 meter per second per second. So in the first second, the value has to jump up from 0 to 9.81. In the second, the value of velocity has to jump up from 9.81 to 2 times of 9.81. And in the third second, or at the end of the third second, the value of acceleration, so the value of velocity, of the magnitude of velocity will be jumped up from 0 to 3 times of 9.81. So the track which is being shown in the form of black color can be shown by you people as an answer of B1 here, starting from the flying aircraft, then you need to move in a curved path towards the ground. Similarly, as the next question, as the next part of the question, you can see calculate the time taken from the instant of release to the instant the parcel reaches the ground. So let me try to calculate this time taken. This time taken cannot be calculated by considering the horizontal component of speed, because in horizontal direction the speed is constant. So constant speed equals to distance covered divided by time is the formula suggested. But this formula cannot be applied because we don't know the horizontal distance covered by the parcel, but we know the vertical distance covered by the parcel, which is equals to 63 meters. And as you know, that there is a uniform acceleration in the vertical direction, means the velocity is changing in the vertical direction uniformly. There is a uniform change in the velocity. So that's why the three equations of motion, the first one is v equals to u plus ad. The second one is s equals to ut plus half ad square. And the third one is v square minus u square equals to 2 times of as. Yes, a will be replaced with small g when there is a case of free fall. Here the parcel is falling vertically downwards in the presence or absence of air resistance, whatever is this, but it is falling freely. So in these three equations, we can change the formula a little bit by writing v equals to u plus small g into t, s equals to ut plus half small g into t square, and finally v square minus u square equals to 2 times of gs. Students, I have chosen the second formula s equals to ut plus half ad square, because I know that I have to calculate the time taken by the parcel. Time taken from the instant of release to the instant the parcel reaches the ground. As you know, vertically, the initial speed was equals to 0. Yes, you can see at the time of release, there the vertical component of speed was equals to 0, while the horizontal component was equals to 42 meter per second. As we are applying this formula in the vertical direction, because in the vertical direction, the parcel is traveling with uniform acceleration. So that's why when I have substituted 0 in place of u, the formula becomes s equals to half gt square. In place of s, I have substituted 63, the given distance in the vertical direction. In place of small g, I have substituted plus 9.81 because it is the downward journey. And in downward journey, the value of 9.81 will always be taken as positive. And finally, t square, from t square, we are going to calculate the value of time. By simply arranging the formula, and finally, by getting the square root of both sides, you will obtain the value of time equals to 3.58 seconds in three significant figures. But as you can see, the whole data is up to two significant figures. So I'm sure that in the end, your examiner will accept the answer in two significant figures only. 3.58 means 3.6 seconds. So you have to convert it into 3.6 seconds and you have to write it here. Second is given here for your convenient. That's why the marks of this question are 2, not 3. And then onwards, now I'll move towards the third part or the next part of the question. The next part of the question is calculate the vertical component of the velocity of the parcel immediately before it reaches the ground. This time your examiner is asking for the vertical component of the velocity. Means in the vertical direction, he is asking for the final component of velocity. As you know, in a vertical direction, the initial component was taken as u, which was 0. But now your examiner is interested in the final vertical component of the velocity when it hits the ground, before it reaches the ground or before it is just hitting the ground. So once again, I have taken the help of the equations of motion, uniform equations of motion. V equals to u plus gt is applied. In place of u, you have used 0. In place of g, we can use 9.81 plus 9.81, and it is a downward journey. And in place of time, we have used the actual value of 3.58, not the rounded value of 3.6, but here I have used the actual value of 3.58. And both of these will be multiplied with each other. Your final answer will be 35.16. But the final answer should be for the two significant figures or in two significant figures only. So that's why I have given the rounded value of 35 meter per second. In the next part 4, your examiner is saying determine the speed at which the parcel reaches the ground. As you know, as far as the horizontal component is concerned, it remained equal to 42 meter per second because there is no force in the horizontal direction. And without a resultant force, acceleration cannot happen according to the Newton laws. So in the horizontal direction, from the point of release to the point when the parcel hits the ground, the horizontal component remained equal to 42 meter per second. While we know that when the parcel was finally hitting the ground or about to hit the ground, its vertical component was equals to 35. And if we'll use the Pythagoras theorem, because horizontal and vertical components are both making an angle of 90 degrees with each other, so the resultant yellow color can be taken as the hypotenuse of both by applying the Pythagoras theorem. So by applying the Pythagoras theorem, we can calculate v square equals to 35 square plus 42 square. By applying this formula, finally, we can obtain the value of the total speed or the total magnitude of speed, which is being obtained by combining the horizontal and vertical components of speed, and that must be equal to 55 meters per second. This is my first video. regarding the past paper solutions of Unit 2 kinematics. And in the second video, you'll see that we'll be solving the next question. So, Allah Hafiz from my side.